In this video, I'm going to cover three topics: no planet B, Dyson spheres, and the Kardashev scale. Now, what do the following have in common? The President of France, the Secretary General of the United Nations, and the journal Scientific American. Well, let's take a look. So here is the President of France giving an address to the United States Congress. And in that address, he says, by polluting oceans, not mitigating CO2 emissions, we are destroying our biodiversity, we are killing our planet. Let's face it, there is no planet B. And next we have the Secretary General of the United Nations. And what does he have to say? Well, as I said often, we don't have a plan B because there is no planet B. Next, let's move on to the Scientific American. So here's a Scientific American article from 2014. And again, we have, let's remember, there is always a plan B, but there is no planet B. And one more Scientific American article. The world needs a plan B given its dire state. There is no planet B. So why are all these people saying that there is no planet B? Because they are essentially saying that we have a climate crisis and the Earth is our only possible habitation. And therefore, as there is no planet B, we are all stuck. We are stuck on Earth. We are not going anywhere. There's no possibility. There's no planet B. That's it. That's our future. We are here on Earth forever. No planet B. And that's just bad science. It is bad science. As the calculations in my book shows, just our solar system, okay? I'm not even talking about going outside our solar system. Just our solar system, which is in relatively easy reach. There is a mass and energy for 438,000 trillion humans, which would equal a population of about 54 million Earths. I consider everything in the solar system within easy reach. It takes about a year to get to Mars right now, whatever. I'm not even thinking about other galaxies or anything like that. So there's not just one planet B that we could go to. There are actually something like 54 million of them within easy reach. Okay, so let's move on to Dyson spheres. And Freeman Dyson was a wonderful scientist. He was really someone who had all these out-of-the-box ideas and really great intellect. And one of the things he said, like one of the things he thought, and I have to confess, I also, while I would lie awake at night trying to fall asleep, I also thought of things like Dyson spheres. And I said, yeah, that should change the wavelength of what you observe of the what we should observe of different stars, you should see more towards the infrared. And so Dyson also said that, okay, if you're looking for alien species, then what you can, like, one way to detect them is that you look at a star and you see that the wavelengths which you're seeing are almost like completely dark in the ultraviolet optical wavelengths, but are bright at the infrared wavelengths. And this essentially follows from the idea that if a species, an alien species, is harnessing the energy of its star for more life, then it is going to, the free energy which is necessary for life, it is going to harness that free energy, and the waste heat which will come out will be in the infrared wavelengths. Okay. So, what do the calculations in the book tell us about this idea? Now, yes, life requires energy for its existence, but life also requires technology and raw materials. Okay, so technology, we can assume that, given our current knowledge of physics, that Dyson mega structures are possible. But what about raw materials? Now, the thing about raw materials is that this book actually goes through calculations of how much raw material would be needed if we were to build habitations in space. And what that tells you is that the percentage of the sphere at Earth's orbital distance, a radius equal to the Earth's orbital distance, the percentage of the area of the sphere that would be covered by space habitations would only be about 12%. So certainly, 12% may be enough for detection. So if you see, if you have a good theory for what the spectrum should be, and you find that some stars are deviating from the predictions by about 12%, yes, it could be that they have used the mass to build these space habitations. And that's assuming that the other solar systems are similar to our solar system. There could be some solar systems where there is more mass available in a usable form. So, however, it's quite unlikely that it will be entirely covered. So I don't expect the wavelengths in the optical and ultraviolet range to be completely eliminated. If you were to use all the mass in our solar system, you would just get to about 12%. Okay, so 88% would still go through. So the point again is that the resource constraint for space colonization is not energy, it is mass. There is plentiful energy in space in our solar system from our sun. There is also plentiful mass, enough if we were to convert use all the mass, we would have the carrying capacity of our solar system would increase to about 438,000 trillion humans. But it would still not use all the energy of the sun. We would just be using about 12% of it. I've already discussed uh, an alien civilization, or even us, we are not likely to use most of the energy of our star. So Kardashev categorized civilizations based on how much of the energy they could harness. Okay, now, however, based on the calculations in the book, what we see is that the limit is not energy. The bottleneck is not how much energy you have for expanding life beyond our home planet. It is rather the amount of mass which is there.